Um, yeah, it was really interesting for me to grade this. Like I said, most people got an A, so that's good. One thing that happened with number 3, create a box plot, is that some people had trouble making evenly spaced horizontal scale. And so if you don't make an evenly spaced horizontal scale, then your graph's not going to be accurate, and so you might draw the wrong conclusions if you don't have even spacing on your scale. So that's pretty important. The skewness of the data, okay, just most people got that fine, but skewness is where the data is spread out. So some of you had data which was spread out on the left so that the left whisker was longer, and that would indicate left skewness. Some of you had data which was spread out on the right, and so then the right whisker of the box plot would have been larger, so then that's right skewed. So it's where the data is spread out, which is what tells you where the skewness is. Now, some people said it seems like there's more data on one side compared to the other, but you have to be more specific about that. What do you mean by one side or the other? If you're talking about the median, half the data is on the left to the median, half is on the right. So it's not a matter of how much data, it's a question of how spread out the data would be. So that's how we determine the skewness. And then, let's turn this off here. Outliers. Yes, outliers. Outliers are data values which are separated from the main data set. So in order to describe where the outliers are, you would have to say, these are the outliers because there is a gap between that number and the main data set. If you find unusual values using the empirical rule, that does not tell you where the outliers are. Okay, those are two different things. Then number 7. Number 7 was an interesting question. Determine whether or not the empirical rule applies to this data set and explain your reasoning. If you simply consider, is this bell-shaped data, then you should most likely draw the conclusion this is not bell-shaped data, so therefore the empirical rule normally would not apply. So if you say it's not bell-shaped, so you should not use the empirical rule, then that would be correct. Okay. If, however, you actually use the empirical rule and you said, well, the empirical rule contains most of the data with maybe one exception, and those things are not very far away, so therefore it seems like this does apply in the situation, that would also be considered correct, because if it works with the data that you have, then that seems to indicate it's reasonable that it's kind of bell-shaped, all right? Because the empirical rule gives you good information compared to the data that you're actually looking at. However, this is something that we talked about in class, neither one of those ideas is always true. The box plot does not always tell you what the thing actually looks like. And the fact that the empirical rule contains a certain amount of data does not necessarily mean that it's a good idea, right? So most people got that right because they said it's not bell-shaped. Correct. Some people got it right because they said it seems to apply to most of the data, and so then it seems reasonable that we would use it. Some of you did not have either one of those things, and some people got that wrong, okay? But most people got it right, so we're okay. In order to really know how that works, you would have to actually be able to say and explain the reasoning process, and it would have to be correct reasoning, okay? So if you say something that's not valid, then you would not get that correct. Okay, so are there any questions about anything here on test number 2? Specifically, if you want to know what your overall grade is at this point, I haven't yet put these into the textbook system, but if you just add together your scores from test number 1 and test number 2, that gives you a pretty good idea of where you stand grade-wise. So, yeah. So then the next thing that we would need to do would be to deal with the material in the homework set regarding probability. And I guess I will describe it this way. It's always kind of risky for me to allow you to use the helps on the assignments, because what that means is you just look at the assignment and you just follow the directions the way they did it, and you do it for yours with just different numbers, and it works. Okay, that's true. Same thing is true for the practice test. I put things on the practice test which are very similar to the actual test, and it's like, oh, this looks pretty much the same, put in these numbers, make it work. The trouble comes if you don't actually understand what's going on. You know how to follow the recipe, but you don't know why to do a thing. And that will come later as we go through more of these situations where it's like, okay, what does this actually mean in this context? But I'm not too worried about that, because if you can follow the recipe and get the right numbers, that's good. And then when we get to the point where we're actually using it, by then you'll feel more comfortable with it, and hopefully that'll make sense to you and you'll be able to understand it. So it's okay for you to just get the right answer without knowing exactly why or exactly how everything works. So if I go to the actual assignment here, most people are in decent shape as far as that goes, but is there any question that you might have about this homework set number 6?
Question 3.
Question 3. All right, let's do that. So I think I need to allow Flash. It's crazy. You should be able to allow Flash if you want to allow it whenever you want to, but they don't. Okay, so question 3. Now, what I'm going to do is use the numbers that are generated by my program here. If you did yours and the numbers were different, hopefully you can understand it still. Okay. So here we are. We have a person who purchases a life insurance policy, and it has a certain annual payment. And then it has a certain probability. Now, there are 2 ways to do this problem. Now, we'll do the easy way and then we'll do the hard way. Okay? The question is asking us, what's the expected value of the policy for the insurance company? So we want the long-term average for the company. Well, if we look at the situation and we say, well, what's happening to the company? The company is getting money, $360 every year. So they're going to always get $360. What is the expected value of their loss. How much is the company going to lose in this process? Well, they're going to pay that money out if the person dies, okay? So when we say, what's the expected value, which is the mean, it is the sum of this thing, which is the value of the thing, multiplied by its probability. So then when we say, what are the options here? And how much value is there? Well, either the person is going to die or they are going to live. If they die, then they would have to pay out this $200,000. So that would be a loss to them of $200,000. What if the person lives? Well, they are not going to pay this, so they are going to lose nothing. Okay. So this is the loss to the company. If they die, if the person dies, the company loses this much. If the person lives, they don't lose anything. And we're only looking at the expected value of the loss for the company right now. So then we need to know the probability. So then the probability that the person will live is 0.999052. So the probability that the person will die will be 1 minus that number. So then that would be 0.000948. So then when we say what is the expected value, it would be multiplying this loss number times that probability number. That would tell me how much the company would lose. Okay, anybody got that number for me? If someone has the number, I would certainly love for you to tell me what it is so I can write it down.
189.6, but that just seems wrong.
189.6.
Negative.
Negative. If I take 200,000 times this right here, I get this number, negative 189.6. Okay? That is the expected value of the loss per person. You want to say it that way? Okay. This is the chance that one person dies. This is how much they would pay out if they died. So this is the long-term average. So then when we say, what is the total expected value of the policy, that would be $360 minus 189.60, or plus negative 189.60. So I think that's 350.40, is that right? Or is it
170.44.
170.40? Yeah, oops, I forgot the other part. Yep. So the company is definitely going to get $360 from each person. For some of those people, they are going to die and the company will have to pay out. But by using this formula, we figure out what is that average. the average amount of payout per person is this 200,000 times the probability that that would actually happen. So then by combining those two numbers, we get the expected value of for the company, which means the company is actually going to make a profit on every policy that they sell. That's necessary because otherwise they would not exist as a company. They have to pay all of their salaries, they have to pay all of their employees' insurance, they have to have all their buildings, all of their computers, all of that has to come from this $170. Now, most insurance companies are fine. If you ever visit an insurance company, they have nice buildings. They have lots of people with lots of money. Well, that's okay. This is how they get it. Now, the fact is, most people don't die, so that means they have a lot of money that they can use and they can invest it in various things, and they can gain percentage increase year after year on those investments. So they have a lot of money, and if they know what they're doing, they can make a lot of money work for them. So that's how this works. This is the easy way to do this problem. The other way to do this problem is to think about the $360 as a gain for the company, and then the $200,000 as a loss, and put them both into the same chart. So you would say the person might die, the person might live. If they live, you get their $360. If they die, you would pay out the $200,000, but you would still get that premium of $360. So then you have more complicated calculation here. And then you'd put in those probabilities again, multiply those out, and you'd get a total number, which would come out to be this number here. So you can do it that way, saying if the person lives, they gain the premium. If the person dies, they lose the payment, but they still gain the premium out of there. Multiply by those probabilities, add those numbers together, get the answer. Now the reason why I put this in here is because this is showing you how businesses can make decisions if they understand probability. Life insurance does this. Car insurance does this. I don't know, did we talk about that at all? I'm not sure we did. If you have good grades, can you get better car insurance? Yes. Why is that?
Shows responsibility.
It shows responsibility. Well, regardless of why, the fact is people who get good grades don't have as many accidents. So exactly how that works, the insurance company doesn't necessarily care about that. They just want to lower the chances of paying out money. So if they attract a bunch of people with good grades, they don't have to pay as much. So they can charge you without having to pay out. That means they make more money. So that's why they do it. It's also true that insurance companies recently have been having people put little GPS devices on their cars. If you put a little GPS device on your car, it will track how fast you go and how fast you accelerate when you're at a stoplight, or how fast you put on the brakes, or what part of the country you're actually driving around in. You might say to the insurance company, oh, I spend all my time in La Crosse, but actually you drive to Chicago every weekend. Then they're like, well, no. So your insurance rate would go up because your actual driving does not correspond to what you told them. And so then they'll give you a break on your insurance if they can, in a sense, police your behavior. They can keep track of what you're doing And then they can say, hey, you're a lousy driver. Guess what? You have to pay more for your insurance. AAA, they actually have a thing where they will use your phone to track your behavior, and then they will tell you, hey, guess what? You're driving crazy. You should not do that crazy thing. And they have an app that will help you to drive better so that you don't have as many accidents. Why would they do that? Because then they don't have to pay to come get you when you have an accident. So that's the same thing. They want to change their probabilities by encouraging better behavior on the part of their customers. So that's how this works. And again, this is how Google works. This is how Facebook works. Google and Facebook exist to make money from your buying behavior. They want to find out what you're likely to buy and put advertisements so that you are likely to buy things that the advertisers have. And so then you buy the thing, the advertiser makes money, Google makes money, so the internet. Because you're able, the information about what you like will change those probabilities and make it more likely that you will buy that Iowa State University sweatshirt that you've wanted for all these years. Because you searched for Iowa State football and Iowa State basketball and Iowa State events. And so they're like, hey, let's pitch you some sweatshirts that say Iowa State on. And so then you say, oh, yeah, that looks good. You click on it, everybody makes money, and the internet keeps working. All right, there we go. Any further questions at all about this question here? Okay, so let's back that off a little bit. If we look at the practice test coming up here, oops, wrong one. We're already in 3, aren't we? You will see that we have this probability of socks. And then we also have the probability of having somebody as a rider in a wheelchair. What will happen? And those would be the questions that are from this section. And then when we say observed probabilities, that's a pretty simple question. You take the frequency divided by the total of the frequencies, and then that gives you the observed probability for those things. Then we had this table, right, where you would find the mean and the standard deviation based on a certain number of days and the probabilities as they're listed here. Let's do another one of those, just for practice sake. So let's say that I've got students in the daycare, and we're going to have how many, let's see, I don't know. If one little kid hits another little kid, I don't know what you would call that. Maybe violence. Let's call it violence. Okay, how much violence are these children doing to each other? Some would be no violence. Are violent incidents. Some would have 1, 2, and let's say there's somebody with 6. And then we have the number of students. And let's say we have 36. the and okay, so I want the mean and standard deviation for the number of principles. And then I want you to answer two other questions. Should we use the empirical rule? And what are unusual values? All right, check with your neighbor, see if your neighbor has good stuff going on here. Okay.
This.
All right, make sure you have looked at someone else's paper. Do not do this by yourself, please. Talk to someone else. If I need to call security, I can do that. I want you to talk to someone else about what's on your paper. They will pick you up and throw you at someone. Well, at least that's the theory. I do not want you to continue working on the problem. I want you to look at someone else's paper and find out what they did and compliment them on their penmanship and find out what they did on the problem.
So this is relatively. And then you take x, which is the violence category, times p of x to get the mean value. Then you add in, you average all of x, total score. And then obviously the standard deviation is x squared times p of x, and you still take violence squared. So 0 squared times 0.6 would still give you 0. Or 1 squared times 0.15. And then you add those all together, plug it into the standard deviation part of it, minus the mean value squared, and that'll give you your standard deviation.
All right, and tell us when you are going to
I think we're going to use that card just like otherwise it's
All right.
Yeah, I was trying to totally.
Hillary, what do I do first? Okay, I need to find the probabilities. How do I do that? Okay. That makes sense? Okay. So when you have a situation like this, in order to find mean and standard deviation, you have to get the probabilities first. So in order to get the probabilities, you take the number of students, find that total, and then take each one of those numbers and divide them by the total. Hillary, what's the total? 60. If you had not done this part, you cannot do the rest of the problem. Okay? So this is where you would start doing something like this. And let me just say, on the exam, when I ask you to find probabilities, you have to know that this is what you're going to do. And when I give you the probabilities, then you need to start from there and finish off the rest of the problem. Okay? So we need these probabilities. Hillary, what do you got for numbers?
0.6, 0.15, 0.2, 0.05.
Okay. There we go. All right. Casey, can you tell me what I need to do next?
X times px, you take the students times the 0.6.
No, I don't. I don't take the number of students.
The violence.
Okay, the number of incidents, yes. I take the number of incidents multiplied by that. Melissa, is that what you did?
Yeah, but we didn't do the first one.
Oh, you didn't get the probability.
Yeah.
Okay. All right. Gabriella, do you have a question?
Yeah, so how did you get like the results of the PX?
Okay, probability is defined as the items in the specific set divided by the total number of items. So we have 36 students in this category. We have 60 total students. So I take 36 divided by 60. That's where that number comes from.
Okay.
All right, Kaylee, you got numbers for me for the next step then?
Nope, pass.
Okay, can you tell me how to get the numbers?
Nope, pass.
Okay. Casey, can you tell me how to get the numbers for the next step?
You take. You mean after you take the 0 times 0.6?
Yes.
After that?
After you get 0 times 0.6,
So then you square x, so then you take.
actually no. If I take 0 times 0.6, that gives me a 0 here.
Oh, yeah.
Can you tell me what the rest of those are?
1 times 0.15, so 0.15. Then 2 times 0.2, so 0.4. And then 6 times 0.05, so 0.3.
Okay. So, Casey, can you tell me what to do with those numbers?
You add those up,
What do you get?
0.85.
What is that?
That is your mean.
That is the mean. All right, Kayla, does that make sense?
Yep.
Okay. So, now we know the mean. Mean is 0.85. Abigail, does that make sense, that 0.85? Okay, what does the mean actually represent? Okay, what is the data? That is a great question. I want to know what is the data. When I'm doing this problem, what is it that I'm actually measuring? Somebody answer that question for me. What am I measuring?
The percentage of violent incidents?
It is not.
The average?
The average what?
The average of violent incidents?
The average number of violent incidents. 0.85 is the average number of violent incidents per student. It's not a percentage. It is an average of those numbers. Does it make sense that that is 0.85? Why would you say yes, Abigail?
Because 36 has 0 incidents.
Okay, so there's a lot of zeros, so that's going to mean it's going to be relatively small, and then these things go up from there, but there's not a lot of them. So it's somewhere between 0 and 1, it's 0.85, that's the average. So that's the average number of violent incidents per student. Okay,
I'm confused.
all right.
How did you get 0.4 and 0.3?
We take x multiplied by the probability of x. This is x. That's what we're measuring. So if I take 2 times 0.2, I get 0.4. If I take 6 times 0.05, I get 0.3.
So is 60, is that P? Is that what P is? I'm a little behind, sorry.
Okay, when you say 60, you mean this right here?
No, I mean, like at the bottom of the number of students.
Okay, this is the total number of students.
There's not like a marker for that at all, so we just make a number.
Okay, when we are finding the probability, that means we need to know the number of the specific set divided by the total number. So if I want to say, what's the probability of being in this category? I have 36 students in that category. I need to divide that by the total.
And that's where you get.
So I'm taking 36 divided by 60 in order to get this number, probability. Okay, these are good questions. Good for you to understand what's going on. So yeah, keep this going.
So I was squaring the x.
Okay,
So is that a
When-
different?
yes, we're not there yet. We need to do that when we do the standard deviation, but we haven't done that yet. We're still doing the mean. The formula for the mean is this. So we take each of the data values, multiply it by its probability. That gives us that column. We add those up, that gives us the mean. Okay. All right, so this is how this works. If the question is, how do I find the probability of these data values? I take the number of measurements, or the number of students, and divide by the total. I take the number of students for each category, divided by the total. That gives me my probability. So this is saying to me, 60% of the students did not have any violent incidents. Okay, so these numbers, even though they're decimal numbers, they're telling me how many out of the total number of students. This 0.6 would represent 60% of the students, and so on. But the formula uses decimals. So that's why I need decimal numbers right here. But once I get those numbers, then if I want to find the mean, I go through the calculation in the formula. I take my data value, number of violent incidents, multiplied by the probability for each category, add up those numbers, and it gives me the mean. And if I ask the question, what is this actually measuring? It is the mean of violent incidents per student. Some people had no incidents. Some people had 6 incidents. What's the average number of incidents per student? That's what I found right here. All right, any further questions about this right here so far? Okay, so this is the mean to find that. Now we need to find the standard deviation. Okay. So hopefully now that you all have the probabilities up here, then finding that standard deviation will not be quite so bad. So let's see. Crystal Wright, can you tell me what I need to do next?
So you take the mean minus the student.
Actually, no, that's not what I need to do next. Tia, can you tell me what I need to do next?
Yeah, you do like 1 to the second times 0.5 and 2 to the second times 0.2. Do you
Okay,
want the answer here?
I do.
Okay, so for the first one, it's 0, because,
Okay, yes.
and then the second one is 0.15, and then the next one is 0.8, and then it's 1.8 for the last one, and it equals 2.75.
Okay, so I'm going to correct what you said about this. This is actually the square of the data value times the probability.
Yes.
Okay,
Say.
so you said something else, but it doesn't matter.
Obviously, 0.
Okay. So then we need this column of information in order to be able to find out what the standard deviation actually is. And that is going to look like this. Question?
I got something different for the last two, those data values. I did 2 squared times, and then 6 squared times, and I got 1.6 and 10.8.
Okay, if you take 2 squared times 0.2, then you get 0.8. If you take 6 squared times 0.05, then you get 1.8. You can't multiply them times this column. You have to multiply them by this column. We have to take this number squared times the number in this column here, not that column.
I see what I did wrong.
So what I normally do is I put arrows on top of those 2 columns to make sure that I put those together correctly. Okay. So, Hunter, you got this information square?
Yeah, next step is 175 minus 0.85 squared.
Okay.
And that gives you it's 2.2 or 2.027. 2.02.
Okay, and that's,
And then you square that gives you this energy.
okay, so when you get through to the end, you end up with a 1.4.
That's your standard deviation.
Okay. All right. Any question about this so far? Okay. So, Mariah, should we use the empirical rule?
Don't remember what the empirical rule is.
Well, that'd be good. All right. Mara, can you tell me, should we use the empirical rule?
Yes.
Okay,
Can I answer it?
sure.
Okay, so you do the mean.
Sorry, I'm not gonna allow you to continue because you're not on the right track.
Wait, what?
Okay,
She made sense. That makes sense to me.
should we use the empirical rule? Should we use the empirical rule? If I'm asking you that question, you should be looking in your notes when I talked about doing this problem, and I said we should or should not use the empirical rule. You should have written that down in your notes, that I said whether we should or should not use the empirical rule in this setting. You should not be just sitting and saying, well, I'm not sure about the empirical rule. You should be looking at your notes when we talked about this previously, and I told you the answer to this question, so that you would not have to wonder what the answer is, because you would look at it and you would say, oh, that's right, I remember, we went over this before, and you said. The answer. Should I use the empirical rule? No. I should not use the empirical rule. It's easy. When you turn and you look at the other page and it says, oh, by the way, we should not use the empirical rule in this situation. Then when I say, should you use the empirical rule? You say no. That's first answer. Second answer is, why not? But,
Well, I was just gonna say, since I wasn't here on Thursday, can you?
I certainly can. I certainly will. And all of your friends are right now going to tell you. Nah, maybe I'll just do it for you. Why should we not use the empirical rule? 2 reasons. First is, it's not bell-shaped. Second is, we don't need it. The most important thing is, we don't need it. We don't need the empirical rule. It's crazy for us to use the empirical rule. What's the goal of the empirical rule? There's a question.
To determine unusual values.
Yes. We don't use the empirical rule to find the unusual values because we don't need it. So then that gives us the next question. What are the unusual values and how do we find them? Alyssa, can you tell me? All right. Can you tell me what unusual values are? What that definition is? Okay. Gabrielle, can you tell me what unusual values are?
They are data values that are separate from the positive data.
Nope, that would be outliers. I want to know what unusual values are. Alex, can you tell me the definition of unusual values?
It's less than 5%.
Things that happen 5% of the time or less, that's correct. Okay. Why are we not going to use the empirical rule?
Do you get percentages?
We already have the percentages. So what would be the unusual values here? 6. Here we have a list of probabilities. These are telling us how often these things happen. This one is 5%. So that means it's unusual for somebody to have 6 violent incidents. So we don't need the empirical rule. We use the probabilities. Okay. So we're going to take a break for 10 minutes. We're going to come back at 2 o'clock.